This video will focus on lines. Sketching the graph using a couple of points, using a point and the slope, recognizing whether you have a horizontal or a vertical line. Those are fairly easy to graph. And also being able to find the equation of a line, given some information about the line, some details about the slope, or what points are on the line and so forth. But we're going to look at a few definitions first here. Our main one right here is let P be the point consisting of x1, y1, Q the point consisting of x2, y2. These will be two distinct points. Assuming that x1 does not equal to x sub 2, the slope m of the non-vertical line L containing the points P and Q is given by this formula. So basically saying subtract the values of the y's coordinates, y2 minus y1. That'll go in the numerator. In the denominator, you'll have x2 minus x1 in that particular order. So make sure you subtract in that order, otherwise your sign is going to be wrong. And of course, the condition is that x1 cannot equal x2. If x1 equals x2, L is a vertical line and the slope of the line M is undefined. And that's because you're going to wind up with 0 in the denominator. So here are the situations you can have. Obviously, you can have a horizontal line here. You can have a vertical line. You can have a slanted line that'll have either a positive slope or a negative slope. The one I have there passing through the origin here that has a positive slope, those will go up. The ones with negative slope will come down this way. And that'll be, of course, because of the slope. Okay, the way it slants the line. Positive slope, it's going to slant it up. A negative slope will slant it down. So notice here. Let's say this point right here will have this vertical line. Say that point is the point 70. So there's 70. One unit above it is the 0.71. Another unit more is the 0.72, 73, and so forth. If we go down, we have one unit below that point would be the 0.7 and -1. Another unit down, 7 and -2. And of course, you can have fractions, but I'm just using the integers. So basically, all the points on this vertical line, are going to have the same x component. The first component is going to be the same. And then the y value is going to, of course, vary from positives down to negatives and so forth. And notice over here, suppose this point for the horizontal line, suppose that point is 0, 7. So if I go 1 over here, I start at the origin and I go 1 over and then go up, that'll be the 0.17. I go 2 over and then go up, that'll be the 0.27. Over here to the left, 1 unit to the left, that'll be -1 and go up, that'll be the point up here, -1.7. 2 units to the left over here and then go up, -2. 7. So in this case, for the horizontal line, you notice that the y value is always the same. It's always going to be 7. The x is going to vary from 0 to positive numbers to negative numbers on the left. So that's why we can say that the equation of this vertical line is x equals 7. The y value can be any number. Whereas for the horizontal line, the y value is always the same, so the equation of that line is just going to be y equal to 7. That's always going to be the case. Okay, so we'll point out over here. So look at this right here. This is called the point-slope form of an equation of a line. An equation of a non-vertical line with slope m that contains the point x1, y1 is given by this formula right here. So this tells you that if they give you 1 point, you can find the equation of a line if you know the slope. Just plug it into this formula. Now, it's possible that instead of giving you the slope, they'll give you the 2 points that the line passes through. So if they give you the 2 points that the line passes through, you can find the slope and then use either one of the 2 points, it doesn't matter which one, and plug it into this formula, and that's going to give you the equation of the line. So now, what I just mentioned, the equation of a horizontal line is always y equal to k. Okay, based on what I just talked about, the equation of a vertical line is x equal to k. And again, let me remind you over here, again, for the horizontal line, we said the y component is always the same. All the points have a same component of y component of 7. So when you use this formula here, you're subtracting the y's because all the y's are the same. The numerator is always going to be 0. And the denominator, you're subtracting the x's, and in this case, the x's are not the same. So you're going to get some number. It could be positive, it could be negative, but this will be a number. 0 divided by a number, as long as you do not divide by 0, it's going to be 0. So that's why we can say that the slope of a horizontal line is always going to be 0. And notice for the vertical line, we said this was a point 70. And we said that the x value is always the same. The points on this line would be 7, 7, 1, 7, negative 1, 7, 2, 7, negative 2, and so forth. So in that case, the x value over here on this one is the same. So 7 minus 7 is going to give you 0. Can't divide by 0. That's why we say that a vertical line has undefined slope, or sometimes we just say it has no slope. Okay, so now let's go back to this. So there's your point slope form of a line. The equation of a horizontal line is y equal to k. And remember, horizontal lines, again, have a slope of 0. The equation of a vertical line is x equal to k. And vertical lines have undefined slope, or we can say no slope. And then the second, or the next equation, is called the slope-intercept form of an equation of a line, because this gives you the slope of the line based on the slope, and b is the y-intercept. Now keep in mind that when they say y-intercept, that's really the point 0b. Y-intercept is the point 0b. But if we say intercept b, or intercept of b, it's understood to be 0b. So this basically tells me that if you know the slope and you know the y-intercept, you can easily generate the equation of the line using this formula. And then the next one is just either the standard form of a line, sometimes they call it the general form of a line. It's just in this form, the x and the y are on one side, and then you have a constant over here. Now if c is 0, this could just be ax plus by equal to 0, which means the line passes through the origin. Okay, so now using this information, we're going to look at the following problems. Work each of the following problems. This one says graph the line through the point 1, 5 with slope equal to 3. So they give you the point that the line passes through, and they give you the slope. Okay, so let's go. This will say 1, and then 1, 2, 3, 4, 5. Okay, so 1 over and 5 up, so the line passes through that point. So the slope, they tell me the slope is 3. But I always think of the slope as, I was thinking of the slope as a fraction. So I'm just going to write it as 3 over 1. Okay, so remember the slope formula, on the numerator you have the difference in the y's and the difference in the x's. So I want to point out to you again here, if you have any line and you have this point right here, here's where the slope is defined. I go so many units on the horizontal this way and so many units up. So let me just draw this little triangle right here. So let's say this is some distance y, and this is some distance x. So it's the horizontal, the slope then basically is going to be the, this is the horizontal run, and this is the vertical rise. Okay, so this distance y, whatever it is, over x, is basically what the slope is. And if I picked two other points over here and form a triangle, the slope again will be given by whatever this distance is right here over this distance here. The vertical rise and the horizontal run here is always going to be the same. It's based on similar triangles. That's where that comes from. That's why you can pick any 2 points on a line. Doesn't matter which ones. You use that formula for slope, it's always going to come out to the same number. So now getting back to this problem here, it passes through the point 1, 5. It has a slope of 3 or 3 over 1. So the 1 is the horizontal run. So I go 1 unit over, okay, right there. And then if I go 3 over, up I should say. So let's say it's 3 up from that point. That really tells me then that the line is going to pass through this point also. So once we know the 2 points that the line passes by, or through, we can draw the equation of the line. So basically now I know that the line is going to pass through those 2 points right there. Because I got 1 over and 3 up. Okay, let's clear this. So that would be the graph of that one. Okay, now the next one tells me, again, same thing. We pretty much did this the other way around. The graph of the line with y-intercept of 3. So graph the line with y-intercept of 3. Let's go back to this one over here. And let's delete this one. So this one has a y-intercept of 3. So let's go up 1, 2, 3 units. And the slope is equal to -1, third. You can leave the -1 there. You can put it with the -3, but just follow the sign. If the run down here is positive, which it is, +3, you go this way. If you put the negative with the 3, then you go the other way when you do the horizontal run. But this way, I just leave it and say, okay, I'll go 3 this way, and negative, the rise in this case is the -1, so it comes down instead of going up. So it goes like this, 1 down. That point should be on the line. So we know 0, 3 is in the line. And we also know that this point is on the lines. We only want the graph here. And we come back over here then. And that'll be close enough. That's the way the line would look. Okay, if I'm going too fast, just feel free to pause the video, try to work it out your own, and then come back and see if you got it right. Give the equation of the line through -3, 0 with undefined slope. So here it says give the equation of the line through -3, 0 with undefined slope. Well, undefined slope means it's vertical line. So the vertical line, as we mentioned, always has the equation x equal to whatever the x is. Because every point on that line is going to have the same first component, or the x. So in this case, x equal to -3 is the equation of the line. Okay, the next one says, give the equation of the line with y-intercept of 2 and slope of -3. Okay, well, here we want to use the slope-intercept form, which is this right here. We looked at that earlier. So just plug in the value for m. You know the slope, gives you the slope, gives you the y-intercept. So you just write this as y is equal to slope, that's m, so we put it where the m is, so it'd be -3, x plus, and then b is a y-intercept, that's a 2. So y equal to -3x plus 2. is the equation of that line. Do this. Okay, the next one, find the equation of a line through the points -1, 2, and 5, 3. Okay, so here they give you the 2 points. So probably the formula that you want to use here is the point slope form. This one right here. Anytime you're given 2 points, you can use the point slope form. You can use the 2 points to find the slope, and then you can use either one to come up with the equation. So let's see how that works here. So let's first find the slope. Okay, so again, difference in the y, so that'll be 3 minus 2. So that's going to be on top. That'll be 1. Okay, 3 minus 2. Make sure you subtract in the same order when you do the other part. So now 5 minus a -1. So now subtract the x's. 5 minus a -1. Because you're subtracting, the double negative makes that -1 a plus. So that this becomes a 6. To complete it, you look at the formula. It's y minus. You can use either point here to get the equation. So you can say okay, y minus 3. Let's use the second point. Is equal to, and then it's the slope is 1/6. And then it's x minus 5. Sometimes they're going to ask you to give the answer in a certain form. So if they say find the equation of the line and leave your answer in point slope form, then you can leave it this way. Now, if you use the other point, it would be like this. Y. So now we're using the point -1, 2. It'd be y minus 2 equals 2, and then the slope is 1/6. And then it's going to be x minus the -1, so that'll make it a +1. Now that's the answer also. And that's the same line. That's the same line. It doesn't look the same. The equation of that line, it looks different. You see y minus 3, and the other one has y minus 2. You see the 1/6, that stays the same. The one has x minus 1, the first one, the second one has x plus 1. But just to show you that it's the same thing, let's write over here, I'm going to do it up here. So y minus 3 is equal to, and I just want to multiply through by 1/6 here. So this will be 1/6 x minus 5/6. So multiplying by 1/6, 1/6x, and then minus 5 times 1/6, it'll give me -5/6. Okay, now let's add 3 to both sides here. So what I'm going to do is I'm going to write this in slope-intercept form so you can see they're the same. So what I'm doing is I'm solving it for y. So I'm going to put it up here. Y will equal to 1/6 x, and then this one here over here, minus 5/6 and plus 3. Now I have to add these two here. So let's put this over 1, and then it'll be, have to get the same denominator, so this will be minus 5/6. And here I'm going to multiply by 6 to get the same denominator, so that'll be 18/6. Okay, now same denominator, now we add a -5 and 18 is a plus 13/6. So they might say you to solve this problem and give your answer in slope-intercept form. Well, here's your slope-intercept form if you use that first point. Now, Now I'm going to do this one and show you we should get the same thing. So let's see. Down here, y minus 2. Okay, again, I'm going to multiply it through by 1/6. So that'll give me 1/6x. When I multiply through the parentheses, and 1/6 times 1 is 1/6. Okay. And now I'm going to add 2 to both sides. So this is going to cancel this 2. I'll get y on that other side by itself, and I'm going to put the 2 over here. And I'm going to put it over 1 because I need the same denominator. Okay, so now notice I'm going to multiply here by 6 and by 6, so that 2 over 1 becomes 2 times 6 is 12 over 6. So we've got 12 over 6. Sorry, yeah, 12 over 6 and 1/6 is 13/6 over 6. And 1/6x. So I got the same thing. That's what you get if they ask you to write slope intercept form. Okay. Otherwise, depending on what they ask you, this is a correct answer. This is a correct answer, because if you simplify those and write it in slope intercept form, they come out to be the same thing. Okay, so now let's cancel these. Now what do we got next? Find the equation of a line through the point 3,7 and -1,7. So notice here, remember, 2 points determine a line. So if you were to plot these points, you go 3 over and 7 up. And then -1, that's to the left, and 7 up. You draw a line through those 2 points, it's a horizontal line. So if it's a horizontal line, that means the y is always the same. That's why the equation will always be y equal to some number. In this case, because the y value is always the same, the equation of the horizontal line, in this case, is y equal to 7. Cancel this now. Go to the next one. This one's straightforward. Give the slope of a line with equation. Give the slope of the line with equation y equal to -7x plus 9. Well, that's it's solved for y. So remember, if you have the equation solved for y, whatever multiplies the x is your slope. So no problem here. And y equal to -7. That's your slope. Next one, give the slope of the line with equation 3x plus 7y. Now you should be able to do this without doing any calculations, just in your head. You should know, since they just want the slope, that means if you have the equation solved for y, whatever multiplies the x is your slope. So you should be able to see without even working this out, the slope is -3 over 7. And if you can't see that, then solve it for y. Say, okay, 7y equals, so just like solving equations here, we're moving terms over. So when you bring that 3x over to the other side, you change the sign. Okay, you got that. And then this is a plus 21. Divide everything by 7 to solve for y. You get y is equal to, dividing by 7 here, that 7 cancels, and then over here divide by 7, that'll be -3 over 7. That's the coefficient of the x. And then divide the 21 also by 7. By 7. So this will be plus 3. Now they ask you to find the y-intercept. That's 7. That's 3 rather. Y-intercept is 3. Slope of -3 over 7. That's all they wanted here. But if they ask you for the y-intercept, it would be 3 or the point 0, 3. Now find the equation of the line. So it should be find the equation of the line through the point 0, 3, and 7, 0. Well, we have 2 points. So you know a point and the slope. They don't give us the slope, but because they give us 2 points, we can find the slope. So in this case, go ahead and subtract the y. So let's do it this way. 0 minus 3 is a -3. And then in the bottom, subtract the x's. Same order, 7 minus 0 is 7. So now we have that. We want the equation. Now we know the slope, and see we have the y-intercept there, 0, 3. So we can just write it out. Y is equal to negative 3 over 7 x. That's your slope-intercept form of a line. This would be plus 3. Again, always read the instructions. They might say find the equation of the line, but they might want it in another form. The form we gave here is the y-intercept form. This particular one didn't ask the form. So if it's just like this, it's any answer. But if you're doing something on the computer, read the instructions, because they might want it in a different form. They might want it in the standard form. AX plus BY equals C. So let's say they wanted it in the standard form. Then what you would do is always clear the fractions. I want to multiply everything by 7. So this will be 7y multiplied by 7, both sides by 7. 7 here, and then this here, multiplied by 7. Those cancel. This will be negative 3x. And then the 3 gets multiplied by 7, so that's 21. And then usually we want all the x's on the same side, and the y's, the x and the y on the same side. So let's take this over to this side. It becomes a 3x, and then plus 7y. Just leave that there. So the standard form is ax plus by equals c, and that equals to 21. There it is. It just so happens to be the equation from problem 8. 3x plus 7y is equal to 21. Hope this helps, and we'll see you next time.